Hello and welcome, viewers. Today, we're going to be taking an overview of Python iterables. Python iterables are objects that can be looped over, meaning that they can be used in a for loop or other constructs that rely on iteration. Examples of iterables in Python include lists, tuples, dictionaries, sets, and generators. In the context of Django, iterables are often used to represent querysets, which are collections of objects returned from a database query. Querysets are iterable, which means you can loop over them using a for loop or other constructs that rely on iteration. Iterables are an important part of programming in Python and Django, as they allow you to work with collections of data in a more efficient and flexible way. By understanding how iterables work and how they can be used in your code, you can write more effective and elegant Python and Django programs. So, let's dive into this topic and explore more about iterables in Python class, because we are aiming to explore Django models in the next few sections. This method is called implicitly by iter and is responsible for returning an iterator that Python can use to retrieve items from the object. The iterator returned is often implemented by defining this method as a generator function, which is described in the upcoming generators section. Let's take an example of a Fibonacci class. A Fibonacci class in Python is a class that represents a sequence of Fibonacci numbers. The Fibonacci sequence is a sequence of numbers in which each number is the sum of the two preceding ones, usually starting with 0 and 1. The code defines a class called Fibonacci that represents a sequence of Fibonacci numbers. The class takes an argument count, which determines the number of Fibonacci numbers to generate. The iter method is defined to return an iterator object that generates the Fibonacci numbers. It initializes two variables, a and b, to 0 and 1 respectively. It then uses a loop to generate count numbers, using the Fibonacci sequence formula to generate each number. The first two numbers in the sequence are simply 0 and 1, and are generated by the yield statements inside an if block. For subsequent numbers, the c variable is set to the sum of a and b, and is also yielded. The values of A and B are then updated so that the next iteration of the loop can generate the next Fibonacci number. The for loops at the bottom of the code demonstrate how to use the Fibonacci class to generate and print sequences of Fibonacci numbers. The loop generates and prints the first 5 numbers. When iter is called with an object, it's expected to return an iterator, which can then be used to retrieve items from that object in sequence. Iterators are a simple way of traversing through the items available in one direction, returning just one item at a time until there are no more to iterate over. For large collections, accessing items one by one is much more efficient than first gathering them all into a list. The only method required for an iterator is next, which returns a single item. How that item is retrieved will depend on what the iterator is designed for, but it must return just one item. After that item has been processed by whatever code called the iterator, next will be called again to retrieve the next item. Once there are no more items to be returned, next is responsible for raising the stop iteration exception to tell Python to stop using the iterator and to move on. After the loop, Python will continue calling next until an exception is raised, causing an infinite loop. Stop iteration should be used to stop the loop gracefully, or another exception should be used to indicate a more serious problem. Let's look at an example of a custom iterator called Fibonacci iterator, and a class called Fibonacci, which is iterable using the Fibonacci iterator. The init method of Fibonacci iterator initializes the state of the iterator. It sets A and B to the first 2 numbers in the sequence, count to the requested number of sequence items to generate, and current to 0 since no items have been generated yet. The next method of Fibonacci iterator generates the next item in the sequence on each call, until the requested number of items have been generated. If self current is less than 3, returns the first two numbers 0 and 1 and increments self current. Otherwise, it calculates the next number in the sequence by adding self A and self B, and updates self A and self B to prepare for the next calculation. It then returns the generated number and increments self current. The iter method of Fibonacci iterator simply returns the iterator itself, since it is already an iterator. The init method of Fibonacci initializes the requested number of sequence items to generate count, while the iter method of Fibonacci returns an instance of Fibonacci iterator initialized with the requested number of sequence items. Note that iterators don't explicitly need to define iter in order to be used properly, but including that method allows the iterator to be used directly in loops. Let's repeat the same loop to see if anything have changed. Everything is good.